Hello everyone, this is Mr. Martin. These notes are for the chapter on similarity. We're going to continue with similarity. In this day 2 video number 1, we're going to talk about similar polygons, scale factor, and then how to write similarity statements, and we're going to do a little practice as well. So let's go ahead and get started with some notes about similar polygons. So polygons with the same shape but different size. And we've talked about this a little bit before. We talked about congruent being exactly equal to each other. They have the same shape and the same size. But with similar polygons, they do have the same shape, but they have different sizes. One is like a bigger or smaller version of the other. Okay, polygons are similar if corresponding angles, I'm going to use the angle symbol here, are congruent. We'll continue using symbols to make our lives a little easier. And corresponding sides are proportional. Okay, and what this means is that the matching sides will make equal ratios. Okay, and we'll talk more about that. Okay, the ratio of corresponding sides is called the scale factor. Come on. Scale factor. Okay, so, and that's a number that we're going to use to either make a figure bigger or smaller. So again, the shape isn't going to change, but the size is going to change based on this number called the scale factor. All right, if polygons are similar, then their perimeters are also proportional. Okay, so let's talk about scale factor. And then keep in mind here that the order that you write this in does matter. It makes a difference. So normally we'll write the scale factor of the figure on the left to the figure on the right, but you have to read the directions very carefully. All right, so for this first question, it says, what is the scale factor of triangle ABC to triangle DEF? So what we need to do is we need to find a pair of sides that match with each other. All right, so I can see that these triangles are similar. We can tell by all the matching angles that are congruent, so angle A and angle D, angle B and angle E, and C and angle F. That in itself would be enough to show us that they're similar for these triangles. Okay, but if we find the ratio of all the sides, it's going to be the same too. So let's take a look at scale factor. Let's pick a pair of matching sides. So I'm going to pick the side over here that's between the 1 tick mark angle and the 2 tick mark angle. So then I'll come over here, and these triangles are in the same orientation. So the side that matches with it is going to be the 12. It's between the 1 tick mark angle and the 2 tick mark angle. So if I'm going to find the scale factor, I'm going to make a fraction out of those two sides. So I'm going to have 8 over 12. And then if you remember from the first video that we watched the other day, we always want to reduce. So I'm going to divide this by 4. I'm going to divide this by 4 to get a scale factor of 2/3. All right, and we'll talk about how to use that. So now, what is the scale factor of triangle DEF to triangle ABC? Now we're going to go the other way. We're going to start with a side from triangle DEF And then in the denominator, use the side from triangle ABC. All right, so we could use the same sides. Let's use a different pair of sides just to double check. So I'm going to use this side and its matching side this side, and I'm going to make sure that I start with the bigger triangle because I want the scale factor of DEF to ABC. So that's going to be 27 divided by 18, and I'm going to divide each of these by 9, and I get 3 over 2. All right, so you notice these flipped. So ABC to DEF was 2 to 3, and then the other way, it's 3 to 2. All right, and then the ratio of the perimeters of DEF to ABC, so let's add up the sides in the bigger triangle. So I have 12 plus 15 plus 27 over 8 plus 10 plus 18. So that's 27 and 27 is 54, and 18 and 18 is 36. And let's start by dividing by 9 and see what we get. So that's going to be 6 over 4. Then I'll divide by 2, and I get 3 over 2. So you notice that the ratio of the perimeters and the ratio of the corresponding sides is the same. All right, so I'm going to stop there for this video, and then in the next video we'll continue with similarity statements and some examples, and we'll see you there.